Let's continue going through chapter 7.1 homework. I'll go over 31, 33, 35, and 43. So 31, we have our four functions, four equations. So we're going to first graph them to see how they look and see if we can identify the shaded region with these lines and graphs as boundaries for this enclosed shaded region. So 10 over x, in your calculator you can graph this to help you with this. So this is going to be 10 over x rational function here. X equals 0, which is the vertical line, the y-axis. Y equals 2, and y equals 10. So based off of these four lines, we can see that the shaded region that has these lines as boundaries for each of the portions will be this shaded region here. So now we have to decide: do we do top minus bottom, or do we do right minus left? If we try doing top minus bottom, we're going to see it's going to be 10 minus 2, but then halfway through, or once we get to this portion, then the top curve will change to this 10 over x minus 2. So we're not going to see consistency if we're going from left to right. The graph, we're not going to be able to get a graph that is always consistently above the other graph and have them stay the same, having the same role the entire way through. But if we look at this in terms of right minus left, well, we're going to see a better form, because if we do right minus left, we see that this graph, this 10 over x, is always consistently to the right of the axis of x equals 0. And because of that, we can think of this in terms of a right minus left formula. But if we do right minus left, we have to make sure that everything we plug in has to be in terms of y. So that means we have to convert our function and solve for x. So if y is equal to x over 10, that means if I solve for x equals 10 over y. So now this curve is represented by 10 over y, and this is represented by x equals 0. So that's fine there. Our lower and upper bound is our y value. So y value from 2 to 10. Right curve is 10 over y. The left curve is 0. And so we think about how we can apply the rule. So the rule for 10 over y is this rule 1 over u, which is natural log of u. So 10 natural log of y. This should be dy. Okay, not dx. And then we plug in our upper bound of 10 in for y, minus, then plug in a lower bound of 2 in for y. So we get ln of 2. Now I can factor this 10 out, and I can use log properties here. Ln of a minus ln of b can be rewritten as ln of a over b. So ln a over b, 10 over 2 is ln of 5. We can plug this in our calculator to get 16.0944 as the area. 33, we have a cubic function, x times x squared minus 3x plus 3, which you can see with this curve that I highlighted in blue, and the x squared, which is the parabola here, y equals x squared. Now, we can do the top minus bottom, but the problem that we have to be aware of is the fact that the top curve is going to alternate depending on which region we're in. So I split this up into region 1 and region 2. And also we need to identify these points of intersection, because these are going to be the bounds that we'll be using in our area formula. So to find the intersections, we're going to have to set the equations equal to each other. So we set x cubed minus 3x squared plus 3x equal to x squared. Bring everything over to one side. Combine terms. Factor out the x. Then factor out the trinomial. So we get x equals 0, x equals 3, and x equals 1. So here's x equals 0, here's x equals 1, and here's x equals 3. So for my first region, I see that my top curve is going to be my cubic function. So x cubed minus 3x squared plus 3x will be the top curve for region 1. Okay? And then we go through the formula here. Minus the bottom curve. The bottom curve in region 1 will be x squared. And the bounds will be from left to right, 0 to 1. Okay, so that will take care of the area of this region. Let's move on to the second region. Now the top curve in this portion is going to swap. So my top curve is now x squared, and my bottom curve is the x cubed minus 3x squared plus 3x, this cubic function. Okay. And I'm not going to go through all the work here, but if we go through power rule, evaluate between upper and lower bound, go through power rule, evaluate between upper and lower bound, and that will come out to be 37 over 12. All right, 35, we have x squared minus 4x plus 3. This is a parabola that's opening up. We have the 3 plus 4x minus x squared. This is the parabola that is opening down. So this is obviously a top minus bottom. We just need to find these points of intersection, set the two equations equal to each other, bring everything over to one side, factor out the 2x, solve for x, we get 0 and 4. So we know that this left bound will be 0 and the right bound will be 4. So we plug into our area formula. So top minus bottom. Top is the negative x squared plus 4x plus 3. The bottom will be the x squared minus 4x plus 3. Left bound 0, right bound 4. Everything's in terms of x because we're doing top minus bottom. Combine the terms, we get negative 2x squared plus 8x. So then we apply power rule for each term, and then evaluate between upper and lower bounds. So 4 plugs in for both the x's, and then 0 would just make everything 0. So this combines to be negative 128 over 3 plus 64, which is 64 over 3 as our area. All right, let's look at 43. Okay, so we have f of x equals 2 sine of x. That is going to be this curve here in black. And we have the tangent of x, which is in blue. And they're telling us the left and right bound between negative pi over 3 and pi over 3. Now, these two regions are going to be the same area because they're symmetrical. So basically, if we can just find the area of one region, we can just multiply this by 2, and that'll get us both areas. So we know region 1 is equal to region 2. So to set up my formula for region 1, it will be my left bound, or actually I can just do it from region 2 since I can deal with positive x values rather than negative. So I'm going to go from 0 to pi over 3, and my sine x is the top function in this interval here, minus my bottom function, which is tangent of x, and then multiply by 2. So and then I go through my integral rule. It's 2 sine of x. Integral for sine is a negative cosine, and the integral for tangent is the natural log of cosine of x. Well, actually, tangent becomes negative natural log cosine of x. The two negatives cancel out to become a positive, and then we just start plugging our upper and lower bounds because we've found our antiderivative for each term. So multiply the 2 through here, plug in pi over 3 in for x, so we get negative 4 cosine of pi over 3, which will reduce to 1/2. Pi over 3 in for cosine of x. Cosine of pi over 3 is 1/2, so that'll be down here. And then we plug in the 0. So 0 goes in for x. Cosine of 0 is 1, so 1 times negative 4 will be negative 4. But then there's a negative here, so it becomes positive 4. Plug in 0 in for x here, and cosine of 0 is 1. Natural log of 1 will be 0, so that will remain 0. And then we just combine here. We get a negative 2 plus 4, which is positive 2. And then the 2 natural log of 0.5, we can plug in our calculator to be a decimal value plus 2. We get 0.614.